happen to do anything last week?
No, I didn't do a live stream last week.
Oh.
I was just. I tell you what, everyone, you're just catching us at the very beginning, and we work really hard to get ready for GTC, and then, and I'd say the week or two after GTC, it's everyone takes some time off. It's like recovery time at NVIDIA. Everyone's just in recovery, getting some recharging after like the run up to GTC. It's like, it's so awesome and it's such hard work. Yeah. So that's where I was last week. I don't even remember what I was doing. I just needed a break. I think I think I was just at home doing little thises and that's. We've had such a wild year. Like we've had so much snow here in Utah, and then it's like snow, and like last Thursday, I think it might have snowed a couple inches or like a foot in the mountains. And then it was Friday or Saturday. It was like 60, and all the snow melted, and now it's spring, and we're loving it. Yeah.
Yeah. No, I feel that Lake Tahoe's gotten a lot of snow.
I heard one ski resort in Tahoe is going to be open till like July or something.
Yeah. Yeah.
That's wild.
If you could imagine like 3 people just all standing on top of each other's shoulders, that's how tall the snow was. Like it was nuts.
That is wild. That is so much snow. Well, and if you're from some places, you might think that's terrible, but we need the snow. That's like our drinking water. That's the water that irrigates all of the crops in California. So it's sometimes it's hard when it comes so much, but yeah, we got Ashley's joined us. Ashley, you are always welcome to join us in the live stream. We'd love to have you. It can be a party, but she's, hey guys, and yeah, Jen's. We're not going to reveal Jen's location, but she is in a new place.
Always on Thursdays. I feel like some of you guys forget. Like this isn't anything different on Thursdays.
Yeah, I'm going to share a link with Jen in case she wants to join us because we would love to have Jen. Let me see.
I am here.
Oh, sorry. Ashley. Sorry. Ashley, you are welcome to join us. I'm going to hop on to Slack real quick and just share a link.
So
share a link with you, Ashley.
Multitasking. If you can always pop in and say hi at any point.
There we go. Oh yeah. So we've got these really cool. So Ashley's working on some. We all do this kind of help out here, but she's working on a DLI course. DLI is Deep Learning Institute. Let me share a link real quick because it's such a cool thing. These courses are awesome. So if you want to learn about just about anything NVIDIA, which includes Omniverse, you want to check out DLI. Here's a link. DLI stands for Deep Learning Institute. We have all these hands-on courses. Sometimes they do instructor-led courses. And I would join the NVIDIA Developer Program. You get access to a lot of things, including DLI, and it's really helpful. And yeah.
Mm-hmm. I would also recommend that some of you guys all try to do some courses because some of these courses, once you've completed, you can get a certificate and then you can actually attach that to any of your like social medias like LinkedIn. So, and then you get this like nice little thing that says, hey, I've done this little course in NVIDIA.
Well, and I just got to say, shout out to the DLI team. Whenever I work with them, they're rock stars. They put together fantastic courses. They really care. They just really take their job seriously and just put together great courses. So I love working with the DLI folks. Let's see here. But let's get back to our what we were working on, which is we've got this crank slider. We've added a position sensor. We've added a velocity sensor. We've added an accelerometer. Now we want to try to calculate some forces. So let's get in there and calculate forces. Okay, so let's see here. Let me share my screen. There we go. Here we've got the crank slider. And if you remember from last week, we were trying to hook up, we're trying to figure out the angle. Let me change views here to a top view. So that if once we have the angle between this link and the slider, we can start to figure out some forces that this slider is exerting on this crank. So let's carry on with that, okay? And what we're getting right now is we're getting this position problem, and it's breaking all of our plots. So let's dig in, and I think what's going on here is I'm grabbing a transform, and let's look at my errors again. Key error position was funny because, well, let's just take a look at the first. I'm guessing it has to do with we've grabbing the transform for these objects, for those pins. I'll show you again here. From the top, if we get the position of this pin and this pin and this pin, then we can figure out the vector from here to here and the vector from here to here, which we know is along the y-axis. And with their dot product, we can calculate the angle between them. And we're trying to get the positions of those 3 pins. And here we go. So let's debug this. Let's figure out what we might actually have access to, because it's telling us we're grabbing the transform, and then I try to grab the position out of the transform. It's saying, well, that key doesn't exist. So let's see what keys do exist. All right. So we can look at this A transform. First of all, is it null? Oh, the return value is false. Well, that's not good. Let's see what we're at here. Get rigid body transformation. Get rigid body. So this A transform is coming back. It's not getting anything back. So let's dig into that. Just curious. Let's make sure my string looks good. This one works right up here. It's making the same call. Get physics interface dot get rigid body transformation, and is passing in a path. Get physics interface, get rigid body transformation. Oh. What's this
Did
one?
we figure out if the API was working? Like the API calls for the physics?
Well, yeah, because it's working. It's working right here for a different prim.
Okay, so it is doing it. Is the prim for a transform? Does that get it? Like the path that you have there for world geometry, slider, crank mechanism?
Yeah. Oh, look at this. I even copied and pasted it, and it's calling it again. So this one is working, right? So here I am at A. If we look at current transform, you can see it's got a length of 3. It's got position, rotation, and I don't know what the third one is. I'm not seeing it, but you see that, yeah. So that is working. So that's good. So it almost seems like there's something wrong with this prim path that I'm passing in. What do you think? I can go to
wonder for get rigid body transform, can you do you have to pass it a string, or can you pass it something else?
Well, you know what? There has to be a rigid body there. Should we double check that there's a rigid body there?
Possibly.
Oh, I think I might know what it is. I think I might know it. Oh, wait, just a second. Renan says, isn't that a quaternion? It has 4 variables. The rotation, you mean? 1, 2, 3, 4. Yeah, it looks like it might be a quaternion. We're interested in the position right now, but that's interesting that the rotation looks like a quaternion, although I'm not sure. Yeah. The nice thing about a quaternion, I think it probably is, because here's the problem: is if you have a three, like just like a vector for your rotation, like an x, y, and z rotation, that doesn't actually tell you everything you need to know to figure out a position in space, because it depends on the order you apply those rotations. So if you do the x and then the y and the z, you'll get a different final orientation than if you do like the y and then the x and then the z. And that can get really, so that's why you end up with these like different rotation schemes, whereas a quaternion is just like, that's it. Hey Zia, welcome. Glad you could make it. And let's see here. Let's see. So let's dig in. I wonder, you know what I'm wondering if happened, what could have happened, it would be really such a simple mistake, is we rearranged these pins and stuff in the tree. And I wonder if I just have the old path to where the pin used to be and not where that pin is now. So A is going to be this pin right here. Let's go ahead and let this continue. Let's stop the simulation. And let's just grab this pin. Let's double check that it has a rigid body. Oh, excuse me. Oh, yeah. So our path is totally wrong because we rearranged things. that would definitely do it. So we're basically trying to grab the position of a prim that doesn't even exist, let alone have a rigid body. So yeah, that doesn't work. But see, this pin here's got a rigid body. So let's just right click and copy prim path. Let's come back. I'm going to paste it below just to kind of verify that it's different, you know? Yeah, just a little different. Cool. And let's I'll go ahead and do that for all 3. I'm pretty sure that's, I don't know if that's the only problem, but I know it's a problem, right? So this is something my dad taught me. He was a faculty at BYU for years. When you're solving these engineering problems, is that sometimes is just go ahead and solve the problem that you know is there, and go ahead and solve that, even if you don't think it's related to your final problem. And you'd be surprised how often that actually is related to your final problem. It's great advice just to, if you see a problem, go ahead and fix it, you know? All right. So here's the crank one. That is going to be, I think, C. Whereas, let's just actually, yeah. Oh, no, this is B. So let's copy that one. Copy path. And we'll head back in. Replace that. Mm-hmm. And this crank shaft, oh, you know what? Shoot. We're going to have the same problem here. A different little, this path is correct, but does it have a rigid body? It does not have a rigid body. Okay, we're going to have to fix that. Let's just get this far first. And honestly, I think we know for a fact, I think what we'll do is we'll cheat a little bit. This shaft, it doesn't have a rigid body. So when we try to grab its position, it's going to fail on us. The good news is the vector from A to this, I forget if this is B or C, but the vector from here to here, we know is always 0, 1, 0 because it's directly aligned with the y-axis. So we can just use that as our vector for now. I think we can do that just in the sake of moving forward. And we're just doing a sample here. So let's see. Yeah, C. Oh, we can even see. Okay, so this is A, this is B, this is C. Very good. And we just know that AC, because it's in line with that axis, is going to be 0, 0, 1. So we can take out this. We don't really need to get this anymore. I think so.
Did something change with the calendar?
What?
Because Zia says, glad to be here. Glad to have you.
Oh, yeah. So the add event repeating calendar, the repeating about calendar event, we're kind of redoing some of that. So.
Yeah, you didn't miss it.
Yeah. So we've got, that's a snafu on our side with the add event. Yeah. So sorry. Well, so I'm just trying to think, do I need this position later? Well, let's just start by getting this angle going. I'm trying to well, if I need it, we can add it later. So I don't think we actually need to calculate AC because we know what AC is, right? It's 0, 0, 1 or 0, 1, 0. This is a really Python question. So in other languages, if you just put 0, 1, 0 like this, you end up with integers, and then it can mess up, especially if you do division. Is that a problem in Python too?
Yes.
So you want to probably do like actually put 0.0?
Yeah. As long as the last number is a float, that's what's going to end up returning. So if you do an integer divided by a float, you will get a float back. But if you did a float divided by an integer, you will get an integer back.
Okay. What if I do like, so in C#, the best practice is you'd say like 0f. That says float. Do you do anything like that in Python, or do you just do the point? Because this say, hey, this is a float, not a double.
Right. Yeah. No, you would
do
just
0f or 0d to really say what you've got.
Right.
Is that a best practice in Python?
You just do 0.0.
Okay. Cool.
Yeah.
I'm still plenty of coding experience, but so new to Python. I like it more and more as I use it, but it's definitely some new territory for me.
Yeah, it's a different syntax.
Yeah. So that means we don't need that anymore. Length AC. Oh, just a second. Oh, that's interesting. I just happen to know that. Well, this still works. It's going to calculate the length of AC. All right, let's see if this is working a little better now. I'll put a stop in. Oh, we got to save it first. Let's run our simulation and see if we get a transform now. Great. Okay, that was the problem. Our path was incorrect. So B, how you looking? Yeah, great. The vector B is just this big old long thing. Theta is 1.2 radians. How does that? Let's see if that passes the logic test, okay? That's not. It should be either 0 or 180 degrees. So that doesn't seem right, does it? Because 0 degrees is pi, or no, it's 0. It should be like, right around 0, right around pi, which is 180 degrees, or right around 2 pi, which is 360 degrees, right? any of those, I'd be like, okay, we're in the right range. Let's just let it run for a minute and see what this gets to. Oh, it's changing fast. Let's just let it run for a minute and see what it plots. Hopefully it's plotting something. Okay, well, let's fix that. Well, look at what the heck is this all about?
That's interesting.
Yeah, this is like total garbage, right?
It,
We're clearly making a mistake.
right? Because it should only go from 0 to 2 pi, right?
Yeah, in fact, let's go ahead and set that as our bounds for the plot. We know, yeah, it shouldn't be. It should be. We'll put like from 0 to 7. I guess it could be negative. I don't know if it's gonna be negative pi to pi, or with 0 to 2 pi. I should probably know that.
Yeah. Did your plot stop?
Sometimes it gets a little bit of a graphicsy thing where
it just gets frozen.
Until if I move the mouse off.
Oh.
Especially if I go over to other windows like the viewport.
Oh, that's interesting.
Yeah, I don't know what that's about. Physics is an illusion. It's right if we believe it's right. Yeah, I feel like we can do better than believe in this situation. I've actually thought of doing this. Should we just pause real quick and add some labels because it gets a little we're getting a little lost in our own plots here? Might as well at least say what they are, right? Let's do that real quick. And then we're going to have to dig into why in the world is those numbers so terrible. Let's see. It's actually pretty easy to add labels because we already have a vertical stack. All we have to do is say, just going right here, UI.label equals, oh, sorry, position. Width equals 100. Let's see how that looks real quick. So you can see the label right here. Do we like that? I might center it though, right? So we're going to use Jen's handy dandy centering trick.
I don't know if it's handy dandy.
With UI.hStack. Put that in. We're going to put this into a horizontal stack. Then it's UI.spacer. And then UI.spacer. Like I have to intentionally not do semicolons after every line still. Like my pinky's like going for it. And I'm like, stop. We're in Python, no semicolons.
Yeah. I get the same problem when I go back to like C# and then I'm like, oh, I need to do semicolons everywhere.
There you go. That's looking better, right? Oops. Let's go right here. We'll grab this stack and just copy it everywhere. Yeah, Ashley's been working in Python for a year now and still put semicolons everywhere.
You'll get used to it.
Maybe we can convince the Python people to introduce semicolons in Python in the next version of Python.
No.
Jen says no. We can't do it.
Once you start like not putting semicolons, you'll realize how amazing it is to not put semicolons. Although
until you try to do a line continue. Have you ever done? How do you do a line continuation in Python? Oh, hey, we got Edmar joining us.
Line continuation. Are you talking about like? So
hey,
it's not
Edmar.
like a running line.
Yeah. So if I've got a really long line and I want to continue it on the next line, like a super long string, how do you do that in Python?
You just hit enter.
And it's okay with that?
It depends on what it is. If it's a string, you want to make sure there's triple quotes. But for like what you're doing on line 75, 76, 77, it's okay with that one. But for strings, you should put 3 quotes if you're going to do that.
Yeah, that's right. So VBA is awful with line. So even with this kind of thing, you have to do it's like an ampersand underscore to say I'm continuing on the next line, or else it does not, or else it hates you and won't run.
Although Papa Chuck's idea, add an extension that autocompletes for you. That's a great extension idea. Who wants to make it?
I tell you what, if you've used Visual Studio Community, they have AI that autocompletes for you while you code. It's amazing. I don't know for sure, but I kind of feel like they've been using. It came out like a year or two ago that they started doing that. I wonder if they're using like GPT-2 or GPT-1 to do that auto completion.
Mm-hmm. Ooh, good question. Can I run this on a GTX 1650 and 8 gigabytes of RAM? Please don't say no.
GTC. Oh dear.
No.
No.
Yeah,
I had to be the one to say it. I knew you guys wouldn't.
But here's the deal, though. Let me think. How can we help?
Well, let me
actually,
see. In the viewport, you don't. If you're not using the viewport, right?
Yeah, if you're running Omniverse code, and you do not, if you're not trying to render in real time, you can in fact run Omniverse code without the X card.
So let me show you what she means. Is here we've got. Here's my viewport, and here's my where I pick my renderer, and you can choose other renderers. Like I can choose the Pixar Storm renderer right here, and you can use Omniverse code, and you can use the Pixar Storm renderer.
Mm-hmm.
Oh, interesting. But I probably have to probably not use Fabric or something to get that to run the simulation.
Yeah, so you won't be able to get to run simulations. You'll only be able to do like extension development mostly.
Yeah. There you go. That said, I mean, so if you just want to get into Omniverse at the lowest budget point, you want a RTX 3060, not Ti. And that has quite a bit of RAM. Let me see. And they're pretty affordable. The Ti actually has a higher benchmark, if you will, but it has less RAM. But you can get an RTX 3060. It's got 12 gigabytes of RAM. And Zia's saying, what is the not Ti part? Yeah.
TI.
Yeah, not TI. Where did I just close my window?
Oh man, there's a lot.
I did a Google search.
Yeah.
And you're just gonna want to watch out. So the 3060's got 12 gigabytes of RAM. They're like $350 range or less. Even you might even be able to find used ones around for even less. And this is just, I would say, the cheapest way to get into Omniverse is getting yourself a 3060. You can see the 3060 Ti has 8 gigabytes of GPU RAM. So that's why if you're just, the cheapest way in is to get a 3060. It's not a Ti, the regular 3060. It's got you can load a pretty big scene with that much RAM. Okay.
You know, there is one cheaper way.
What's that?
You could use AWS and install Omniverse there. I'll actually post a link to a video where Drew Cromer just walked you through how to do that. So that you're just paying for cloud time, basically. That's
a great point. And then I've used a 3080 Ti is a really great way to go. Like the 3080 Ti has got good amount of RAM, 12 gigabytes of RAM, and it's really a great benchmark. you can really get a lot done with a 3080 Ti. And then it just gets better, obviously, the better the card you get, the better performance you get. But let's see here. I lost all my windows. Just a minute. Okay. So we're getting these plots now. Well, look at how crazy that one is.
Oh.
Yeah, let's fix. We got to fix this. Something's up, right?
The acceleration's kind of wonky.
Yeah, that happens because of all of them. If you look when I start and when I stop and restart. So if I pause it and then restart, it gets a little glitched in that moment, and I'm okay with that. I feel like I'm sure we could figure that out, and and like Edmar said, the AWS thing, you like you said, you can just go and pay for the time you need. Huh? I don't know how much that costs.
That's a good question. I think he's online. Let me ping Drew. I'll ask him really quick. It's a really good question.
Yeah.
And, I think it depends on some of the options you choose, obviously, because it's up to you what kind of GPU you want.
Yeah.
Well, and I don't know how available they are right now, but DLI has some courses that give you hands-on time with one of these AWS virtual machines.
Oh, this is actually, I'm so glad you just said that. So it reminds me. So next week on Wednesday's live stream, we didn't announce it yesterday because we were still putting the pieces together, but it looks like we're going to have Christopher Scott on our Wednesday live stream at 11 Pacific. What he's going to be showing off is super cool, related to what we're talking about too. He's working with a great company called UME Studio. So it's UME.studio. And what these guys have is a platform that allows you to train and do tutorials live, kind of like we're doing with Launchpad and DLI sessions, where we're using VMs. People can access VMs during the class, so they have all the hardware they need. So they're doing that on their platform. So they have all the hardware on their side. People can jump in, take a training class, and you have a teacher there who's walking you through. But the other part of that, it's not just for training. People can actually use that service for actually working in Omniverse.
Don't you have access for a while after the class ends?
I don't know, actually. It's a good question for him. I'll add that to my list to ask him on Wednesday.
And I don't know for sure about this one, but I know that with the DLI classes we did during GTC, those people have access for 6 months.
Oh, really? Oh, that's great. Wow.
Yeah.
Yeah.
Damn, I should take
And Papa Chuck, he knew the answer. He says $1.20 an hour.
Not bad.
That's not bad. So you could use it for like, a work week for like $50.
Less than the price of coffee. Well, not for an hour.
So, full 8-hour day is like $10. That's not too bad.
I see a good question here, and maybe you know the answer, Eric. Oop, not that one. Too many things coming in. Can Omni deal with satellite data?
You bet. That's the thing. Is the cool thing about it's so can Omni deal with this or that? The question is, can Python deal with that? And if Python can deal with it, you can bring it into Omniverse. You bet.
Mm-hmm.
And so one thing, and I'm not. We're working on just some kind of by hand physics here. But let me think about the demos. Oh, we've just released a ChatGPT demo where we've integrated. We've written an extension that integrates into the GPT-4 API. And that's available on GitHub, and that can show you one way where you might integrate Omniverse with some like RESTful API or that sort of thing.
Mm-hmm.
So, but yeah, basically, if you can do it in Python, you can pretty much bring it into Omniverse. And I found, so web APIs are great, or fine. There are Python libraries that let you get into Windows APIs. That lets you consume .NET libraries. So anything that's available on .NET, you can consume in Python. I think that's the great strength of Python is like when I was in .NET developer, it's always a question in my mind of, well, can I get into this or that library? And it wasn't always yes. I feel like with Python, the answer is always yes. You can just like integrate with anything. Yeah. Oh yeah, that's right. That's a great point. Cesium, that's their thing, isn't it? They do like is that a digital twin of the Earth, or what is cesium?
I think so. Like you can basically generate 3D models of like a city that is captured from satellite view.
Yeah. So yeah, basically, whatever you can imagine with Python, you can integrate it into Omniverse. It's really very flexible. And yeah, when Edmar mentioned the cost of coffee, I couldn't agree completely. Definitely not Jen's. I don't even know.
I meant for an hour. I meant it for an
I
hour.
don't even know how much Jen's coffee costs. We don't want
Vince,
to.
well, actually, maybe Vince's coffee. Vince drinks the expensive stuff.
There you go.
I can tell you that I spend $6.95 every Thursday morning for my coffee.
Okay.
You had today.
Yes.
Nice.
And I finished. And now I'm on to the regular coffee.
So maybe we should write like a digital twin extension of Jen's coffee level or something like that.
You know what? That would probably be pretty cool. Not gonna lie. I would pretty much appreciate it. And then if somebody could take my my Falcon too and make like a 3D model of that'd be better.
That's
awesome.
awesome.
Like the coffee rise up and down.
There you go.
You know, that question regarding satellite data reminded me of one of the partners we highlighted recently, Heavy AI. We had them on a live stream, and they're using Omniverse for telco, so not too different, I guess. And to be able to view and optimize networks, and also for network planning. So I just posted the link to that blog, and there's a real cool image at that blog, give you a sense of kind of how they're using Omniverse. But I'll look at the live stream in a second and post that. That was a really cool live stream. People were pretty blown away by how Heavy AI is using Omni.
Yeah, it's really fun to see how the Omniverse ecosystem just like grow so fast.
Oh my gosh! Speaking of which, so Jen is directly part of this. She's on this thread we're on this morning. But Jen used to work for this great company called Alara Systems. Am I pronouncing that correctly, Jen?
Alara.
Okay, yeah. Alara. But they are using Omniverse to the max. They are using it in conjunction with over 10 different DCCs and apps. Basically, they're doing a visualization with really realistic kind of imagery and also really cool animations for different commercial clients. So we're working on right now on how to tell that story in a live stream and a blog, but I'll see if I can post a link to one of their pages, which is public on it. So super cool. But just on your question of how people are leveraging it, Alara did a really cool thing about for medical. They worked with the Sickle Cell Anemia Society to help use Omniverse to create an animated short to help explain to people with sickle cell anemia how to deal with some sensitive topics in a way that's much more approachable and accessible. So really, really cool. Something I wouldn't have thought that people would be doing right now, but really cool to see. So I'll look for that link, and then we'll keep you posted on the live stream for that one. Jen, you have to come to that one, obviously.
Well, just don't catch me on vacation this time.
I know. Jen was a big part of the ChatGPT project that Eric was just talking about. So Jen, yeah. I swear you were mentioned all over the live stream. We're talking about how impactful you were.
I watched, actually. I was since I was over in Texas, I made all of my friends sit there and watch the live stream with me.
Oh, nice.
We were all doing like a little puzzle, a 1,000-piece puzzle, and I made them watch it. So
very cool. Yeah, it's amazing.
Great question here in the chat. I tried a small simulation with gravity and collision in RTX 2080. Code has no bug, but it is hanged. I think 2080 will run Omniverse, but it's really I would recommend getting into the 30 series. I think a 3060 is kind of like the minimum to where you can I think that 2080 is maybe a little tough.
It should. I mean, we definitely have people using even lesser cards a little bit than the 2080, and it does work. That is a minimum spec, but like Eric's saying, I think it also comes down to your scene, right? He's saying it's, or she is saying it's simple here, but or small, but really depends on
how many rigid bodies do you have?
Yeah,
Yeah,
it
that's a good
really
point.
depends on what you're trying to do. If you're like trying to run things like Isaac Sim and doing like the people behavior, it might hang up a little bit more. If you're trying to generate any kind of like heavy synthetic data, it could also take a lot longer to create that data versus somebody who might have like a 3080 instead. So it really just depends on what you're trying to do.
Yeah. And then if you want to reach out to us on Discord, we'd be so happy to help you.
Yes, and I see that Intuitive Design Lab. Thanks for sharing your work here. I definitely reach out to us in Discord, like Eric's suggesting. Let me see. The best channel for that would probably be, we have a channel called I think it's a job channel. I think where people are posting different projects they're doing and looking for people to work with. So exactly what you're asking for here. I'll post the link to that channel in a second. But great to meet you.
All right. Let's get back to this. I really want to get this angle calculating today. So let's see if we can figure out what is going on. I think one thing we can do to start with is we've got the position velocity here. Here's our theta plot. The range right now is negative. Oh, I don't know what I was thinking there. I did like negative pi halves to pi halves, which is totally the wrong range. Let's just make it. Let's just make it negative pi to pi, a little bit bigger, obviously. And let's see how that works. Interesting plot here. Yeah, that's not right. Something's up, right? It's kind of in the right range, but all right. I think something I know is wrong, or something I think would be a little better. If we go back to these, where we get these vectors, I've noticed that the way we're doing this is we've got A, so we're grabbing the A vector, and then we're finding the AB vector, and then we're calculating the length of AB. And then I think we're kind of normalizing. We're calculating theta here, but I don't know if we got this all right, because typically the way I've done this in the past is to go ahead and normalize AB. So let's see if we can. I think the way I would do this, we're going to say AB is equal to AB divided by length of AB. I'll do an element-wise. Do you know if that? So Jen, will that do element-wise division if I divide an array by a float?
Well, okay. Let me see. So you're just using basic prim. Yeah, it should. In theory, if it doesn't, there should be a math library for that, but I'm pretty confident it should.
Okay. Then I should be able to do this. All right. I think that's just a little cleaner. Oh, AC, the direction is, yeah, that should be okay. Let's see how that looks. Oh dear.
There is nothing to look at.
That's because we cannot divide a list by a float.
Oh, so it's set up as a list. Okay.
Is there like a vector class that I can use that
We
even has a normalized function?
we can use Pixar's GF library that also does normalization and division. So it'd be like capital G, lowercase f,
Let me just
dot.
make sure.
Okay.
So probably need GF here
Yeah.
first.
Mm-hmm.
Okay. So let's say here we've got the position. Let's start with here and say GF dot vector vec 3D.
So that would do integer. So if you want to float, you would want to do 3f.
Okay.
Oh wait, no, 3D is a double, I think. You want a double or a float?
I don't care. Let's do a float.
Okay.
All right. So there we go. That seems. We'll see how that works. And we should say GF dot vec 3f. So now we should be able to say AB is going to be equal to B minus A, right? And then we should be able to say like AB dot norm. Be able to say like AB equals AB dot GF dot normalize AB, right? And AC is just 0, 1, 0, and it's already normalized. We know. Because people say like dot equals GF dot dot AB AC. It's looking about right. Yeah, I think this library is really cleaning things up, isn't it? Doesn't mean we're going to get the right value, but here we got some comments here. I should. Is AR mandatory for digital twin projects? Absolutely not. Nope.
Just sim-ready assets. If you're going to make a digital twin, I highly recommend that you have assets that are sim-ready.
Yeah. Papa Check said something to the same effect. Yeah, this is what's odd that there would be oscillations within the oscillations for theta. I think that's the clue that it's definitely wrong, right? It should be something more periodic. So, and yeah, this GF library. Well, let's see how well it works. If it totally crashes and burns, but it looks like, I mean, I might have wrong syntax, is what I mean. I'm sure the library is great. All right, just a second. Oh dear, we did something wrong.
Do you want to clear that first? And then...
Yeah. Yeah, it's just hitting at every single Python argument types in vec3f did not match C++ signature. Oh, I know what's going on. I just tried passing this whole array in for when I created this vector 3D. So I'm going to say dot x, or it's probably 0. Probably like that, right? And then let's get B here. Same kind of a thing, I bet. Let's I just didn't use the right constructor. Let's see if that works. dot is between a float and a list right now. Oh, wait, what? What's up with that? Oh. gf.vec3f. That's definitely a problem. See if that fixes it. Did I not save it? AB. Let's just put a stop here before dot product and see what's up. Okay. Why is normalized giving me a float? So B is a vector. A is a vector. AB is now a vector. AB is now a float. All right, so how do I normalize a vector with the GF library? Pixar GF normalize. Just trying to look up on the documentation here. If anyone is familiar with the GF library, and they know like what I'm doing wrong here with this normalize call that turns it into a float, I'd be happy to. I could use the help. Oh, maybe it's get normalized, huh? Let's try that.
Yeah, you want to do get normalized instead of normalize. Because normalize gives you the length, I believe.
Okay. Okay, we've got this caching problem I run into now and then. It's not running my changes. So do you usually have to restart Omniverse or just VS Code when this happens?
I try, so there's a couple things I try if it's a cache problem. Is usually I will try to shut down the extension first. And if that doesn't work, then I usually try to close out of Omniverse.
Actually it's not building correctly. Let's see what's up. Invalid argument.
Invalid argument. Shut down extension. So that's calling the shutdown.
Oh, weird.
Undo.
It's failed to start up, and then it failed to shut it down.
Yeah, I think at that point you might want to have to restart code.
Yeah. All right. I'll restart Omniverse.
I guess while that's restarting, what's our live stream later today, Edmar? Do we have one? He's thinking.
Sorry, I'm unmuting. Just so I just posted the calendar a second ago. Today we are done, except for tomorrow. We have developer office hour at 7 a.m. Pacific. For all you early birds, I think that's with Maddie. And then Eric, are you doing one tomorrow?
Oh, no, I just have the Thursday one.
Why do I see one tomorrow of engineering design? Who's this?
Oh, maybe that was supposed to be for today.
Yeah. Okay. So I'll fix that.
That's
So
right.
we have one for tomorrow, and then next week we definitely have a few things going on that are pretty exciting, including the third Isaac Sim Robotics weekly live stream. The first two have gone great. They're rotating developers doing that stream, so pretty fun to watch. Anyone who's into robotics should definitely check out that Tuesday live stream.
Cool.
We're actually thinking, we haven't announced this. I talked about it a little bit yesterday's live stream. We haven't announced it yet or anything or promoted, but I'm thinking it would be a lot of fun to do like a Friday kind of casual live stream of a showcase, show and tell. Basically,
Oh,
we'd go through like people's posts on Discord where they've posted stuff they've done in Omniverse, kind of share those on the screen and talk about them. And if we get some of those people to come join us on live on the stream, that would be fun. I think it might be a really cool thing to do. We actually do have a showcase channel on our Discord server. You can go ahead and click that now, and you'll be able to see some. We just did it this week. We had another channel we were using before called Showcase, but the way it's set up now is you can click on the channel and you'll see all the images together in a grid. It looks really cool, and you could vote on them, add your own emoji. But I thought, how fun would it be to do a live stream on Fridays, more casual, kick back, and kind of look at some of that stuff together. So if we do it, maybe it'd probably be around this time, maybe a little bit later, maybe a normal time, which is 11 Pacific, 2 Eastern.
That sounds like fun.
Yeah, and maybe we could. Jen, have you been working anything on the side? I know you did your cool Christmas lights extension.
I have a lot of things on the side. If if we ever want to show them off, I have way too much. Ashley
Always want to show them off.
Yeah, Ashley's like, how do you have time to do all this stuff? I'm like, I don't sleep.
What's the latest thing you've been working on?
So, well, I mean, one's the secret, but I can say another thing that I've been working on is basically a Pomodoro app. So I don't know if you're familiar with the concept of a Pomodoro, but I've been trying to make my own version inside of Omniverse to get more sophisticated with my UI.
I am familiar, and that sounds amazing. That sounds epic. We should definitely show that off when you're ready to do it.
Yeah, absolutely.
All right, I got everything back up and running. We're debugging. The normalization code is working, and we are getting the same results. So I will show you here.
Same results meaning nothing?
Meaning this weird function going on.
Oh, that's interesting.
Yeah. But here's the thing. Let's actually put a debug in here. So now I'm like, okay, what's not working? Let's just look into these numbers and look for something that doesn't pass the logic test. And so I run this and get a debug going. I'm looking at AB. So this AB vector, it should not be going up and like if you look at our scene, the Z-axis is up. And oh shoot, I can't do that. Just a second. Let me just get you back. And they should be on the same level. So the difference in the Z direction should definitely be 0. And let's take a look from the side I'll show you what I mean here. Let's go for perspective. Actually go to like here we go. So if I come into this and grab those two items, let's just take a look at them because they're right here. Those two should be, oh, and look at that. They're totally not. Those should be like on the same plane. And so the difference in the Z should be 0. in every
Like,
frame.
not on the same plane?
They're not. And so if we take a look at the position, X 159.95 in the Z. What? I'm just drawing with my finger. I know you can't see it. Oh. Yeah, what is up with that? I'm just looking at my transforms trying to figure out what the heck is going on. Because
So it's not 0 in the Z?
no, the vectors are coming back definitely not 0. Let's take a look at that.
So
So
could
if AB, so as AB is B minus A, that should give you the vector from A to B, and it should have no Z. It should have no Z component whatsoever, guaranteed.
So I'd be curious to see what the Z value is there, and then what the Z value it is in Omniverse.
Yeah,
Does
so
that
look
make
at
sense?
this. So here's B. So A is got a Z value of negative 95.15. What? Negative 95.018. Oh, that's sorry. Let's look at B and A by themselves. Here we go. A is negative 95.018. B is negative 95.154. And B minus A is negative 0.136. So non-zero. Yeah. And so then what that means is when we normalize this, we're getting a Z component that's in there. So that alone tells me something's up, right?
Do we have time to fix it in 1 minute though?
We can try something that probably won't work, but something worth trying. We can just kind of fix it. Because if the X and Y's are right, but then that one of those pins is just dropped down a little bit, we can just kind of delete the Z component there of AB, and it might fix it for us. We can just kind of fix it. So we can say AB to 0. I just kind of fix that if they're not quite aligned the way they should be. If that really is the only problem, then this will fix it. My guess is that that's not it. The only problem though. So now we look at AB is just zeroed out the Z. No, that didn't fix it. It's all messed up. So we'll have to dig in some more. I think that the next thing is we just start debugging. These vector things can be a little bit tough to debug, but we're just going to start off by going step by step through and saying, do these positions make sense? And we'll just do the logic check as we go through our calculations. And I think the positions that are coming back from some of these pins are not correct. So we got our recording something back. It is interesting how periodic we got the double periodic thing going on here, but I think definitely not right yet.
Progress though, progress.
Yep, progress every week. We'll get there. So until next time, I guess we'll see you next time. Same bad time, same bad channel.
Have a good rest of the day, everybody.
All right.